gentlemen. It's really a great pleasure for me to be here today and to experience here the warm atmosphere of this university and of the city of Patras. Well, what I plan to do today is not to talk about papillomaviruses and cancer. I just mentioned them. Could I have the first slide, please? I have to do something here myself. Well, I would like to discuss with you, first of all, the present state of our knowledge about infections and human cancer. And as you can see from this slide, we can roughly calculate that about 21% of human cancers are presently linked to infection. Not only to viral infections, about 2/3 of these infections are indeed viral, but clearly bacteria, Helicobacter pylori and gastric cancer plays a major role, and also some parasitic infections, specifically in certain countries like Egypt and Southeast Asia, are also, at least in those places, of high significance. But the important aspect of these identifications came really from the possibilities to either cure or to prevent these types of infections. Curing is possible in bacterial and also in parasitic infections, where indeed by antibiotic treatment or by chemotherapy, full curing can be achieved, but where on the other hand, reinfection becomes readily possible because there's no remaining immunity after curing these infections. So particularly workers in the Nile Delta who are exposed to schistosoma infections, they become readily reinfected under those conditions. Now, in terms of virus infections, we are in a different situation because here, first of all, we do have two vaccines, the hepatitis B virus vaccine and also the human papillomavirus type vaccines, at least against the type 16 and 18, which are presently available, which provide long-time protection. In the case of liver cancer and hepatitis B virus infections, we know already that liver cancer is being effectively prevented since it is being applied in Taiwan to all newborn children at the age since 1984. In the case of HPV papillomavirus infections, we know that the vaccine is preventing the precursor lesions of this cancer, not yet cancer, because the time period which elapses between primary infection and cancer development usually is something between 15 and 25 or 30 years. And since in most countries the vaccine has been licensed only since 2006 and 2007, we still have to wait for statistically significant results. But everyone is convinced that they will come up in the future. Now, it's interesting that we have, at least in certain types of infections which are linked to cancer, hepatitis C virus infection in Europe more important than hepatitis B virus infection for liver cancer, and also for AIDS infection. There exist indeed possibilities to treat the persistent infection in patients, where in the case of hepatitis C, 20 or 40 years later, frequently liver cancer may develop. In the case of HIV, of course, the severe immunodeficiency causes a couple of other kinds of severe malignant conditions, commonly by reactivation and activation of other types of cancer viruses. So here the treatment indeed represents presently a type of therapeutic prevention, if you may say so, because in hepatitis C virus infections, recent treatment protocols permitted in quite a number of cases the elimination of the viruses, and thus hopefully in the future also the reduction of the cancer risk. In the HIV infections, the so-called HAART, the highly active antiretroviral therapy, really provides a lowering of the dose of the virus in the infected individuals, and thus there is already a visible effect reducing specific types of carcinomas, namely Kaposi sarcomas and B-cell lymphomas, which arise in these conditions. So in a way, the identification is an important point. We have with the hepatitis B and the papillomavirus vaccines for the first time the prevention of specific human cancers, of widespread human cancers by vaccination. Do we have a chance to eradicate these infections, particularly as far as HPV is concerned? Yes, but this requires efforts to vaccinate girls globally, and in coordinated efforts prior to reaching sexual maturity. And if we wish to achieve this within a foreseeable period of time, we also have to vaccinate boys as well. That's an important issue which needs much more discussion than it presently finds. But let's not forget at this stage that secondary prevention of cervical cancer, the identification of precursor lesions and the subsequent removal, usually by surgical interventions, is indeed reducing the cancer in those countries where this has been done effectively up to 70 to 80%. And this is the merit of Georgios Papanikolaou, a Greek physician whom, as you all know, worked for a long period of time, particularly in the United States. Now let me say a few words concerning mechanistic aspects of cancer induced by infections. And you will see quickly that there's not one mode of interaction, but there are several modes how potentially carcinogenic agents interact. And we can roughly differentiate between direct modes and indirect modes of interaction. Direct modes are listed here. The continued presence and expression of viral sequences commonly after integration of the viral genome into the host cell DNA, where the presence and expression of this DNA is a requirement for maintaining the malignant type of the cells, as for instance in papillomavirus-infected cervical cancer cells. Another mode would be the insertional gene activation due to insertion of whole or parts of the viral genomes into host cell DNA. Here we know only an example in animals so far, namely the mouse memory tumor virus. Sorry. It's somehow moving by itself. Maybe start to sit here to more advanced, but maybe easier. And the last point, finally, is that there's a continued episomal presence of viral nucleic acid, which leads to suppression of several genes, for instance by viral microRNAs, but I will not detail on this right now. There are a couple of modes by which infections act indirectly. One is the induction of immunosuppression, as in the case of AIDS infection, where, of course, specific tumors due to the immunosuppression arise mainly due to other types of tumor viruses. The induction of oxygen and nitrogen radicals leading to mutation events in the affected host cell. A very important aspect and frequently ignored is the amplification of latent tumor DNA, usually by infection with other types of viruses, but we all helpless type viruses have the property to amplify if the infect cells persistently infected, latently infected by polyoma, papilloma, or single-stranded DNA viruses to amplify highly this respective DNA and inducing changes due to these amplification events, induction of mutations and translocations by infections, and the prevention of the self-programmed cell death, the apoptosis, all aspects which would deserve a more detailed discussion, but time doesn't permit it to go into more details. Let me just point out one slide which I've shown at many occasions, namely that we do deal with very different latency periods between primary infection and the final eventual development of cancer, which lasts from, in only one instance, from a direct effect of the infection resulting in carcinogenesis up to something like 60 years in Helicobacter pylori, in adult T-cell leukemia, and also in parasitic infections, and some which are more intermediate. Now, the only example which exists there where infection really leads directly to cancer really somehow elucidates why we have these different latency periods. Namely, in this case, we deal with an inherited modification in the X chromosome, which prevents an effective immune response against Epstein-Barr virus infections. So these patients, boys, they suffer from a rather severe form of lymphoma, which at least in the past regularly led to death of the infected persons after acquiring an Epstein-Barr virus infection. But The length of the latency period, let me state it this way, I would have to discuss it in more detail at other occasions, clearly indicates the number of genetic changes which have to occur within an infected cell prior to the development of malignant disease. And there's not a single malignant tumor caused by an infection where, in addition, a couple of genetic modifications have to take place prior to malignant conversion. Even so, in some instances, like in the papillomavirus infections, the virus infection may be an essential component of the development of cervical cancer. So the length reflects the number of additional modifications. Now, let me leave it at this stage and address a question which is presently interesting us most. Where exists epidemiological hints from infectious etiology of human cancers which have not yet been linked to infection? And I will very briefly discuss two of these points. I will not discuss the cancers occurring at increased frequency under immunosuppression, also they represent an interesting topic. Also, I will not discuss point number 3, the tumors influenced by basically non-tumorigenic infections. I will mainly address the question nutritional cancer risk factors which are possibly linked to infection. And I will also briefly, if time permits, talk about cancers with reduced incidence under immunosuppression and which are not affected by immunosuppression. These are clearly breast cancers, which are very important cancers. Let me come to the nutritional cancers. If you look into colon cancer, it's quite interesting to see that colon cancer in a large majority of countries, like shown on the left side of this slide, is increasing more or less globally, with very few exceptions. In the United States, as shown on the right panel here, the rate is going down, which is most likely due to effective colonoscopy control of patients. But in most other countries, the rate is still increasing. In particular, there's a dramatic increase in Japan and Korea. I will come to this in a moment again. And there's a rather stable situation in India. So there are remarkable geographic differences in this type of colon cancer. And it has been known since quite some time that there are specific risk factors for colon cancer which are quite important. And that is a long-time consumption of either red meat and of processed meat. Processed meat, either smoked or, for instance, air-dried meat, which are consumed in quite a number of parts of the world at relatively high frequency. There are a couple of other risk factors, but I think I will restrict my discussion to those two aspects here. Now, it's also known that this increase in risk is about 20 to 30% in comparison to other populations, and that the highest rate of colon cancer occurs in countries with a high rate of, particularly of beef consumption, like here listed here, Argentina, Uruguay, New Zealand, USA, but also the majority of European countries. They all reveal a very high rate of this type of cancer. Now, it has been assumed since 1987 that Sugimura and his colleagues in Tokyo analyzed products which are being synthesized in the grilling, frying, broiling, and the barbecuing process of meat. And under those conditions, nitroso compounds, tetracyclic amines, and aromatic hydrocarbons arise. And clearly, if you take those purified substances and inject them into rodents, they cause cancer in many of these instances. And so this seemed to clarify the situation. If not specifically white meat, has been considered as relatively safe. I mean, there's no increased risk after long-time consumption of poultry or fish in large-scale epidemiological studies. And this in spite of the fact that the same chemical compounds, if you prepare these fish or poultry in a similar way as the red meat is being prepared, that this produces the same chemical substances, sometimes even at higher concentrations than in the case of a well-broiled steak, for instance. Now, if you look into the geographic epidemiology of colon cancer, there are a couple of other interesting aspects. Besides India, which has a remarkably low incidence of this type of cancer, Another country, in particular Mongolia, is quite strikingly low in its incidence. As in others, as I said before, Japan, Korea, the rate is high. In Equatorial Africa, the rate is also comparatively very low. Now, if you look into Mongolia, and that is probably the most interesting country in this respect, you can see that the rate is one of the lowest globally. This in spite of the fact that probably in no other country of the world more red meat is being consumed than in Mongolia. They eat barbecued, grilled meat, they eat air-dried meat to a large degree, but the meat consumption is different from the other parts of the world. They eat as a kind of beef, they eat the yak meat, a specific species of cattle, to a large degree. They eat mutton and goat, camel meat and horse meat to a larger degree. And in addition, only recently, some of the European type of beef has been introduced. These cattle do not survive the Mongolian winters, which are very harsh, and they're kept usually outside the cattle, whereas yak tolerated very well. Now, these are the types of cattle which occur mainly as domestic animals. And you can see this on the left-hand upper panel. Is a typical Taurus, the cattle, the common cattle, which is a European, Asian type of cattle. The Indian cattle, the zebus, on the right-hand side and the top. Water buffaloes play a minor role in this respect, and the yaks on the lower part of the right-hand side. Now, there's one consideration which really triggered our work in this respect, because first of all, we do know since a very long time that we harbor a number of human viruses in our body, some of them excreted almost persistently in the infected persons for a lifetime, which so far, as we can say, have no carcinogenic potential, or at least do not induce cancers in humans. And some of them do it rarely, like Epstein-Barr, even iris and HPV are not frequent cancer inducers. Only about 1% of the infected persons eventually develop cancer. But there are others like polyomavirus BK and JC adenoviruses, which have never been found in human cancers yet. If you transmit them to systems in which they cannot replicate, to rodents or to, in the case of JC virus, for instance, to all monkeys, then they are suddenly remarkably tumorigenic under those conditions. And this is one important aspect, namely that in many instances, whenever a virus induces cancer, even human papillomavirus inducing human cancer, the virus genome itself becomes defective, is no longer replication competent, as it was also recently shown quite clearly for the so-called Merkel polyoma virus, which in Merkel cell carcinomas exists in a form which is no longer able to replicate itself. So this really triggered the idea, is it possible that some of our domestic animals with which we live in close proximity harbor similar agents, excreting them over long periods of times, and although they never develop tumors in these, or lead to tumor formation in these animals, due to a long period of adaptation probably of the host to the agent, if they are transmitted to other species, in this case to humans, where they cannot replicate, then in those circumstances they may become carcinogenic. And let's come back to the situation in Japan and Korea. In India, for instance, the Hindu population doesn't eat beef at all. There are some minority groups in India which do eat beef, but it's a relatively low number of them. In Japan and Korea, the rate of colon cancer increased dramatically after the Second World War in Japan, and in Korea after the Korean War, 20 years later, approximately. And if you take the two curves, take these 20 years away, you see that they totally overlap. In addition, the consumption of cereals went down concomitantly. Now, what happened in these countries? It's interesting to see in the middle panel where there's data from the Japanese Ministry of Agriculture. that after the Second World War and after the Korean War, it's the same situation. Large proportions of beef, in particular of meat, also of pork, have been introduced to Japan and Korea. And there's a very high consumption presently taking place of meals, in particular of relatively raw meat. In Japan, sashimi, previously only presented as fish sashimi. Now you see it frequently as raw beef sashimi, as sukiyaki, and also as a so-called shabu-shabu, where you dip briefly thin slices of beef into boiling water, and which is taken out quickly, and then the inner part is usually still raw, the outer part is well done. In Korea, a kind of crude tartar is being very popular, the so-called yukre, which is usually delicately prepared with egg yolk and some vegetables. And now these types of customs are spreading more and more in Southeast Asia, particularly Thailand, Vietnam, and a couple of other countries are taking them over as well, which didn't exist in the same way prior to the World War, Second World War, and the Korean War. In many countries, of course, air-dried beef is being consumed, the Bündnerfleisch in Switzerland, the Wagyu, the Kobe beef in Japan, the Braseola in Italy, and the Biltong in South Africa. And if you're a virologist, for virologists it's quite clear that this type of air drying is the best conservation method for viruses for prolonged periods of time. Now, of course, that raised the suspicion and led to a postulate that there exists a specific bovine factor that may be causally involved in human colorectal cancer. It's probably a relatively thermoresistant agent present in meals of rare and undercooked meat. It may lead initially to latent infections in the intestinal tract, as we see it for many other tumor viruses, and only if specific host cell genes are being inactivated and suppressed, then it may exert some functions which lead to malignant transformation of the cells. So in a way, preceding, concomitant, and subsequent mutational events, specifically those mediated by aromatic hydrocarbons and the other chemical carcinogens which arise in the preparatory processes of the meat, that they should interact synergistically with in the induction of colon cancer. Now this is a model which came out of these types of studies. If you take these lines as a lifespan of about 80 years of humans, that are exposed at arbitrary periods, first of all due to the consumption of raw undercooked meat, to transient and latent infections of the putative carcinogenic agents, and that intermittently and subsequently or concomitantly, the consumption of cooked or cured red meat would lead to mutation events which act synergistically with infections, and inherited types of modifications would basically similarly act as laxi mutation events acquired later in life. Now, so we started to, in our lab, to look into the situation into cattle specifically by analyzing pools of, we received 130 sera from a veterinary station of 130 cows in Leipzig, and analyzed the blood of these cows for the presence of putative possible agents which may be linked to these types of developments. So they were extracted from the blood and purified, and subsequently each of the isolates was cloned and sequenced. And in a way we have by now identified, surprisingly, about 10 novel types of viruses belonging into the, in a broader sense, the nanovirus or circovirus families. These are single-stranded, small, circular DNA viruses which exist at a rather remarkable frequency in cattle blood. And we anticipate, similar to other single-stranded DNA viruses which are known, that these are relatively heat-resistant agents, although a direct proof of this question is still missing. Here are a couple of isolates which we obtained in these cases from cattle. These are all belonging to the same type of family. In the meantime, 3 other isolates came up which belong to the same family. This is obviously a relatively heterogeneous family of agents, and also 2 types of circoviruses which we have, and these are the people who are presently working on these aspects. This is Michel Devilliers, who is at the same time not only laboratory head but also my wife, and a couple of other persons listed here who are quite engaged in these studies. Let me just finish, and these are our involuntary co-workers which interact also here, because they were very important. They delivered the blood for the respective types of tests. Let me just come up at the end with one other point which I would like to stress here. There are a couple of recent studies in particular which imply also an increased risk after red meat consumption for breast cancer in particular. I listed here a couple of these studies which came up. There are some older ones. They're not all in the same line because some are a little bit conflicting, but the vast majority is clearly positive. A couple of other cancers, but let me just stick to breast cancer at this moment. In breast cancer we have the interesting situation that immunosuppression has a slightly protective effect in breast cancer. And we have another animal model for memory cancer in mice, for which the same situation occurs. That is the memory cancer in mice, which John Wittner discovered in 1938, where the virus is taken up from feeding mothers by the milk infectious given to the newborn youngsters. And indeed this virus is infecting the lymphocytes in the pious patches in the gut, and suddenly these infected cells become swelling, produce large quantities of the virus, they are eluted into the blood, and apparently the load of the virus in the blood is one of the respective factors for reaching the mammary gland at sufficient quantities to be inserted into specific sites in certain types of cells where subsequently cancer arises. Some of the sites have been relatively well characterized in the meantime, which are apparently responsible for this effect. Now, if you immunosuppress these mice, then indeed the superantigen producing cells are being suppressed, the virus load goes substantially down, and with this reduction in load, also the risk for memory cancer is reduced under those circumstances. Well, it's an interesting point, particularly in terms of memory cancer, because if you compare the global incidence of memory cancer with the global incidence of colon cancer, as you've shown for colon cancer in females, you can see that more or less there's a similar pattern visible for both types of cancers. Mongolia, again, is a rather remarkable exception here, not exception in terms of the same effect which you see, but here again you have a very low rate of breast cancer as well. Now, there are also a few discordant data which do not fit into this picture, namely, if you look again to the left side, the situation in India, in Japan and Korea, and on the right-hand side for colon cancer, and on the right-hand side for breast cancer, you can see that breast cancer in Japan in particular is also increasing, but at a low rate, whereas colon cancer increased at a very rapid rate during the same period of time. And the same seems to be true for Korea. So there's some discordance of the data, at least in this aspect. Coming back for a second to Mongolia, there's a very slight rise in the incidence of breast cancer, at least between 1998 and 2005, which seems to continue up to today. But this slight rise is slightly more pronounced if you compare the urban population with the rural populations. In the rural populations, the level is almost consistently low, but in the urban population, it goes up. In the urban places in Mongolia, some introduction of the European cattle meat has been taking place, also of dairy products, which could, of course, be the reason, although it needs to be proven definitely. So I will finish this by just stating one further aspect. We presently know that about 20 epidemiological studies point an increased risk of butchers, slaughterhouse workers for lung and oropharyngeal cancer. And this occupational group is regularly exposed to aerosols originating from the handling of slaughtered animals. The oropharynx and the lung should be the prime organs of exposure. So again, although this was initially suggested to be due to the heavy smoking habits of this professional group, even adjustment for smoking did not decrease the risk. So is it possible that here are also infectious agents being transmitted? An open question which deserves investigation. I'm finishing just by stating that we do have good reasons to look more carefully into the situation of many of our human cancers, particularly those where epidemiological exist, which may link them to infectious events, because at this moment we can clearly state that nothing would be better than to identify these agents, first of all for developing preventive measurements, secondly for identifying patients at risk for the subsequent cancer development, and finally and hopefully in the future also for the treatment of the respective forms of cancer. So these are important issues. Fortunately, the situation changed right now. For about 30-40 years, the role of infections in human cancer didn't find very much public attention, particularly not also among the scientific colleagues. That is different in these days, and a number of groups started to work on these subjects. So I'm just encouraging young people, and many of them are sitting here in the room, to look into this question carefully, whether this might be a topic which would be something which deserves more interest and more hard work. Thank you very much for your attention.